Hey, hello everyone, welcome to molecular geometry part 2, which is extended octet. So in last video you learned the 5 basic molecular geometry. We are now going to learn about extended octet geometry. That means a molecule which has a central atom with more than 8 electrons in the outermost shell. So here are some examples which we are going to go over. The first one is PCl5, phosphorus pentachloride. If you draw the Lewis dot structure for phosphorus pentachloride, phosphorus will be in the center, chlorines surrounded by chlorine on all the sides, and don't forget the lone pair of electrons on chlorine. I'm going to try to squeeze it in here in a small space. Okay, so phosphorus is the central atom which is connected to 5 chlorine atoms here. There are no lone pairs on the central atom. There is no lone pair on phosphorus. There are lone pairs on chlorine, but that doesn't matter for our molecular geometry. So only lone pairs on phosphorus would matter, and here phosphorus doesn't have any lone pair. So this gives a molecular shape which is called as trigonal bipyramidal. Pyramidal. Let me erase and rewrite that. Middle. And to draw the shape, we can have phosphorus in the center. Now this is the trigonal bipyramidal. So see how if I'm holding the molecule, there's phosphorus in the center and 1, 2, 3, 4, 5 chlorine atoms. So if I'm holding it like this, there is this base which has 3 atoms, so like a triangle here on the base, and then there is one coming up which can form a pyramid if I connect these dots, and then there is one coming down, one bond chlorine coming down, and it can form a pyramid if I join these 3. That's why it's bipyramidal, and this is trigonal bipyramidal. So I have the 3 bonds in trigonal bipyramidal which are in the plane, and then I have one which is coming up and one which is going down. The one going down we put as dotted lines, one which comes up put them as a we are going to put them as a wedge. Okay. Don't worry too much about the bond angle on this one. You guys are not tested on bond angles for extended octet. Okay, the next one is SF4, which is sulfur tetrafluoride. So you have sulfur as a center, and then you have 4 fluorine atoms. Now if you draw this Lewis dot structure, you'll see that there is a lone pair on sulfur. Okay, and I'm drawing the lone pairs on fluorine. Okay, so sulfur is attached to 4 fluorines, and there is one lone pair on the sulfur atom, and this shape is called as seesaw because this is sulfur and 4 fluorines, and here is the lone pair. So see how there is a lot of space for the lone pair, so it's pushing these bonds down, and if you look at it, it kind of toggles like a seesaw in the playground. So the shape for this is called as seesaw, and the way we can draw this is sulfur in the center, then there are 2 which are in the plane, and then there is one coming out, one in the back. So that's a seesaw shape, 4 bonds with 1 lone pair on the central atom. The next one is CF3. me change the color on this so we can differentiate. So C, chlorine is in the center, has 3 fluorine atoms. Remember, it has 2 lone pairs. If you follow all the rules to draw the lowest dot structure, okay, and chlorine is the central atom attached with 3 fluorines, 2 lone pairs. So this one is T-shape. So if I have chlorine is my central atom and 3 fluorines attached to it. So if you look at this, because of the 2 lone pairs here, it's making as much space for the lone pairs, and this is how the bonds are arranged. So this shape is T-shape. So you have this, all of them are in the plane, 1, 2, and 3. So T-shape atom molecular geometry. Okay, the next one is XeF4. So Xe is in the center. Now, even if it is a lone pair, it's way there on the bottom, which has those d orbitals and things like that, where electrons can move around and form a bond. So it does form some compounds there. So I have 2 fluorines attached. And if I do the lowest dot structure, I'll know that there are 1, 2, and 3 lone pairs on Xe. So Xe is attached to 2 atoms. There are 3 lone pairs. And if you look at the geometry, how does it look like? There are 3 lone pairs which are all around here, lone pair. So they move the bonds in a straight line. So this is linear. Molecular geometry is linear, and if you want to draw the molecules, it's like that. Okay. Now, the next one is SF6. So again, sulfur. Now it's connected to 6 fluorines. So 1, 2, 3, 4, 5, 6, and you can do the lone pairs on fluorine. So if you draw the lowest dot structure, you'll observe that there are no lone pairs on sulfur atom here. So it's just bonded to 6 fluorine, no lone pair on the central atom, and this shape is called as octahedral. Okay, so it's octahedral. Okay, so easiest way to remember is if I draw or attach all these points, there are 8 vertexes. So that's why it is octahedral shape. So if you see there is central atom, there are 4 bonds or 4 atoms attached in the same plane. One is going on the top and one is going on the bottom. That's your 6 bonds.
Good afternoon, Tigers. This is James Williams, your council co-president, here with your afternoon announcement. Hello.
Let's look at the next molecule, that is BrF5. So bromine here is the central atom, and let me just change the color. Bromine is the central atom, and there are 5 fluorine atoms around bromine. And if you draw the 5 and you draw the lowest dot structure, you'll find there is 1 lone pair on bromine and all these lone pairs on fluorine. So I'm just trying to draw those. Okay, so there are 5 atoms attached to bromine. There is 1 lone pair. So this structure, if I have 5 attached and 1 lone pair, so you see how the base has 4 right? So this shape is square, and this is like a pyramid, square pyramid. So the shape is square pyramid, square pyramidal. So to draw that, I have the central atoms. I have 4 things attached to it, which is in the same plane, and then I have one which is coming out as a pyramid. Okay. The last one is XE F5, and let's get a color. So XE here is my central atom. I have 4 fluorine atoms, and if you do all the Lewis dot structure 5 steps, you'll see that there are 2 lone pairs on Fe and these lone pairs on fluorine. Okay, so all the lone pairs on fluorine. So we have 4 atoms attached. We have 2 lone pairs. So this shape is.
Teachers, reminder, we have PLC right after school in the media center. Teachers, just a reminder, we have PLC right after school in the media center. Thank you. Have a great day in the land of the tiger.
Okay, so we have 4 things attached, atoms attached, and 2 lone pairs on the central atom. So this shape is square. Now the pyramid is gone. The top one is gone. So it's square. The top one is gone. So the pyramidal part is gone. So it is square planar because the molecule is in a plane. So I have a central atom and 4 things attached. So these are the molecular geometry of extended octet. Hope you took notes, because in class we'll practice using these molecular geometry and then go ahead and talk about electron geometry. Thank you for watching. Bye.